Good to see you.
So thank you all for coming. And great to see you all again. Hopefully your summers are going well. We've got I think a very interesting agenda here. We'll have our typical updates. There's a lot to update, a lot that's happened so far this summer. And then Christine's been working hard and really trying to help us understand, what is happening there with the flows through the breach and changes in the south arm. So she's going to review those things, and then I want to make sure that we talk through some of the numbers things at the end. But that's the agenda. I'll get tapped in here shortly. But I think the first thing that we had on our agenda was we'll do introductions. We'll just go around the table and online. And so I'm Jeff DenBleyker with Jacobs Engineering.
Christine Rumsey, USGS.
Ryan Rowland, USGS.
Joe Addisy, Compass Minerals.
Greg Miller, Water Resources.
Thomas Bill Steels, Brian Trimcoe.
Linda Freitas, Friends of Great Salt Lake, and this is Art.
Andrew Rupke, Utah Geological Survey.
John Love, Wildlife Resources.
Ben Stireman, Forestry Fire and State Lands.
Jim Harris, Division Water Quality.
Ed Balling, Forestry Fire and State Lands.
Here, David O'Leary, U.S. Geological Survey.
Angela Dunn, Forestry Fire and State Lands.
Andy Carlson, USGS.
Ben Holcomb, Division Water Quality.
Laura Vernon, Water Resources.
Travis Anderson, Morgan Salt.
All right, and then online, I see Jake Alexander with Forestry Fire and State Lands, Jess Stern with UGS, Justin Hipple, and Kyle Stone, Layla Mahdi, Bill Brown, Rob Dubuque, and Craig Miller there at the top.
I'm here too.
Oh.
He's everywhere.
There's two of you.
Great.
I wonder how many meetings Craig is really
All right, so I think the first thing on our agenda is just reviewing our meeting summary. And so if you remember, we had a meeting in May, I think May 27th, which is our normal meeting, went through our normal agenda. And one of the things that came out of there were some recommendations that we should consider modifications to the berm. Then we met again in June for an hour, and out of that came a recommendation to the Division of Water Quality and Forestry Fire and State Lands to look into actually modifying the berm. And so the summary I sent out this time was just for the June meeting, and wanted to just see if anybody had any comments that they'd like to change or any gaps in it. And I guess if not, entertain a motion to approve that summary.
So move.
Thank you, Thomas. You have a second?
I second. Joe.
Thank you, Joe. All right, all those in favor of approving the summary, say aye.
Aye.
Any opposed? All right, it carries unanimously. Thank you. All right, well, the next thing on our agenda is just an update on the lake. I don't know if Ryan or...
Yep, I'm sorry you got to put up with me again. I think I start this off. Christine's bringing up the slides. Okay, we're gonna jump in. Go ahead, and we'll just jump right in.
Great.
There's our disclaimer. This is important. There's a lot of provisional data. There's a lot of assumptions that we are open with. So keep that in mind. Here's our official disclaimer. All right, let's just start off with what you guys already all know. I'm hoping you guys are always looking at the Great Salt Lake Hydromapper or looking at our data through the National Water Dashboard, et cetera. South Arm Great Salt Lake elevations, I'm showing data from October 1st, 2021 to the current period. The period of record low is 4188.5 set in 2022. The most recent data here at the end of the plot, the daily value on August 5th came in at 4190.6. That's down 1.7 feet since the seasonal high that was not influenced by the sesh. That little blue peak right there was a sesh event. Okay, I'm not counting that. So we're saying the seasonal high was about 0.3 of a feet lower. And so the bottom line is, since that seasonal peak, the lake is down about 1.7 feet. All right. This puts us 2.1 feet above the period of record low. All right, so something to keep in mind going forward as we anticipate, snowpack, next season's evaporation, etc. All right, similarly for the North Arm, the daily value computed for August 4th came in at 4190.2. That's down about 1.4 feet since the seasonal peak. This guy back here, and that's 1.7 feet above the period of record low, which is also 4188.5. Both the north and the south have the same period of record low. Okay, so that's the lake elevation data. Now let's get into major surface water inflow on our stream gauges. First, I just want to remark that these cumulative flow hydrographs are coming from a relatively new USGS software package called HiSwap. That's the Hydrologic Surface Water Analysis package. This is a package of Python code that helps you visualize USGS data. Publicly available, just Google it and you'll find it. That's what was used to make these plots. So here we have a plot of cumulative discharge in acre feet. Y-axis is, the y-axis is in acre feet, it's a linear axis, and the x-axis is a water year. The bold black line is the current water year. This top dashed line is the highest ever measured cumulative flow for this site. That was in 1984. Small dash line at the bottom, lowest measured cumulative flow, 1992. And then the green shaded zone is the 25th to 75th percentile range. And so the middle of that green zone would be the median, right, the 50th percentile. As of August, a couple of days ago, the total volume of water passing this gauge was at 541,000 acre feet, plus or minus a little bit. Next slide, or hit the next button. Exact same format plot. This is for the Weber River near Plain City. And first of all, note where the black line is relative to those benchmarks. So at this site, we're hugging the lowest measured cumulative flow. Currently, we're at 54,000 acre feet at the Weber River near Plain City. All right, next slide, or next plot. Goggin Drain. I made a huge error on this guy last time we met. I had added a 0 to this total here. You might remember some very surprised faces in there. You guys knew I was wrong. You were just being nice to me. I'm not saying, hey, there's something really wrong. Yes, I made a mistake. I apologize. Anyway, as of early August, the total volume of water passing this gauge is 46,882 acre feet. And we're just below the 25th percentile. And then the Farmington Bay outflow gauge, same format plot. Currently, or at least as of July 29, there's some more recent data that are incomplete, some rating things we're trying to tweak. So we only have daily values up to July 29 to compute that bold black line, but close enough to the current period. It's about 195,000 acre feet that have passed that gauge so far. Keeps us within this 25th to 75th percentile range. If you add all these numbers up, and also to put this in perspective with the historic data, I have this bar chart. So here's the current water year 2026. If you add up those cumulative flows for all those gauges, we're at about 837,000 acre feet. But I have the previous water years here going back to 2014 on this bar chart. All right. So last water year, 2025, we had 1,161,000 acre feet. I'm rounding, as you can tell. 2024, 2,100,000 acre feet. 2025, 2.3 million acre feet, and so on. But you can see currently We are above 2021 or 2022, which were really, really bad years. But anyway, this plot gives you a nice perspective on what the total volume of flows look like at these gauges back to 2014. Are there any questions?
Very cool.
Yeah. Okay, and then we'll wrap up my little segment here before we do a little more a little later in the meeting, but just recent discharge measurements of the Great Salt Lake Breach at Lakeside. So this is the far west breach. This is not the new breach. Basically, we've had zero flows at this site since April, and that's indicated with this flat line here at the 0 mark on the cubic foot per second scale on the y-axis there. This is showing data from October 1st to the current period. So basically, we're high and dry at this site right now, and we'll have more as we cruise through the agenda.
Okay, quick update on salinities. We actually, the last set of samples we got was in June. So I'm going to show those real fast, and then I'll show you some updated salinities from other locations. But from our South Farm monitoring network, as of June 22nd, 2026, the salinities ranged from 122 to 124 grams per liter. That's up about 4 or 5 since our seasonal low in April. And the water column is pretty well mixed at this point. Our more recent salinities we have from the new breach, we measured salinity yesterday, and we're getting 131 gram per liter. So that's kind of what we're seeing at the breach. Now, north to south flow, which we are seeing now, is 273 grams per liter. And then we also got a measurement from Saltaire, where the lake elevation gauge is for the South Arm. That was also 131 gram per liter. So that, based on those, if we assume those are representative of the South Arm, which this time of year is a pretty good assumption, we're up 13 grams per liter since April. And actually, I'll use those August measurements for the fall and spring predictions, just because I would rather rely on our more recent measurement rather than trying to estimate from June forward. So I'll just give you a little info on that. The volume weighted methodology requires measurements from our 4 sites from where GSLUP collects samples. So the most recent volume weighted salinity estimate we have is from June 22nd, and that is 123 grams per liter for the upper brine layer volume weighted and the full depth. But GSLUP did go out yesterday, so we have a new fresh set of samples, and we're working on getting those salinities measured right away. So I can send out an updated volume weighted salinity probably later today or tomorrow for everybody. Looking at our South Arm salt mass trend. So this is from 2022 to the present. South Arm salt mass is in millions of tons on the y-axis. And our most recent, again, measurement, which I used for GSLUP sample set from June 22nd, was 856 million tons as of June 22nd. You can see we're kind of still following that same trend of decreasing 27 million tons per year, roughly. If we look at those values in the context of elevation and mass, we can kind of see where we fit as of June 22nd. 123, 856 million tons, and we were sitting at 4191.4 at that point, so kind of clustered right around this black dot cluster. If I just put on our August 4th measurement from those 2 locations, again, salinities are 131 gram per liter, 864 million tons if I extrapolate that concentration across the volume of the South Arm at that time, which the lake was at 4190.6. So I think that's our best estimate of what current conditions are right about now. I'm sitting at 131 grams per liter. Okay, and I think that's our first segment, the end of our first segment.
Great, thank you.
Unless there's any questions.
Well, great. Well, Ben, you're next on the agenda, just an update on the berm. Yeah, what's been going on there?
Well, we lowered it per the recommendation of the committee. I wanted to give a shout out to Water Resources for helping with the construction oversight. So Eric and BJ did a great job making sure that happened. And then also to Union Pacific, they also volunteered their time and labor and everything again. So that was awesome. We were able to get that done within days of asking them. So everything went as planned. I think they got it down to the elevation of 4183 and as uniform as possible per Craig's request. I guess we'll have to see if surveys represent that, but we try to get it down to a nice uniform elevation. And right now it's open. We're looking forward to understanding, what type of flows we're seeing through that and reconvening as we get more information. But we did work with USGS to increase monitoring, so I think that's also well underway. So we can keep tabs on this. I think that's all I have. Unless anybody has questions about it.
So building the berm seemed pretty easy for the railroad. This seemed like it would be more difficult. Did they say anything about how?
I think they were pretty good. I mean, they got it done in like 2 days, so I think it was pretty simple for them. So I expected it might be a little more challenging to get down, but they made quick work of it.
Awesome.
We do have one slight issue, which is there was a cessation order of their quarry based on some requirements that need to be met. So if we end up needing to raise the berm again, we're gonna have to probably source some rock or figure that out. But we're trying to work through that and figure out what can be done or how we can help on that. But
Strong's not.
What's that?
Our Strong's not pit.
I'm not.
Strong's not is just about a mile away from Lakeside.
Oh, good. So it's positive. Nice. Yeah, I don't think it's insurmountable. I think it just ends up not being free, which we've been pretty accustomed to lately, and that's pretty nice. So it allows us to invest into other activities. So anyway, that's all I have to report on that.
Okay. Any questions?
Maybe you can give them some cookies.
Yeah, I did like that. I think the first time we took them to dinner. So
I was amazed when like, oh my goodness, you got it. It's done.
Yeah.
that included everything. Making sure everybody who needed to know knew, and all of the other pieces. So there was a lot of work in between, and we had a lot of help from water resources and from
Ben, would you revisit, you said the sesh thing, would you kind of help me understand, Union Pacific is concerned about that at a certain level?
Oh,
Help me.
well, I mean, I don't know what conversation you're referring to, but I think in general, these sessions have been known to take out rail cars if they don't protect the causeway properly.
Right.
So they're constantly like rebuilding rock walls or
Okay.
stabilizing them and keeping the railroad from sinking. But in our case, I think we all agree that a sesh event is what took out the berm the first time it lowered and made its own V-notch. And then subsequent lowering of that has been through just erosion based on like it didn't have all the protective rock that would have been in there. So now, one of the things that we're considering and discussing is, through the Jacobs proposal, when we asked about like a more intelligent structure that could, go up and down from the bottom and all the things, and we realized that's gonna be really expensive. But one thing that did come of that is the geotech was the big question mark on that, but we could probably learn a lot about what's necessary for the geotechnical, stabilization of that and what support a structure, just by simply starting that project by doing a component of putting in like jetties in front of the berm. And I think that even if we stuck with a rockfill structure, those jetties would protect from seshes and make it so we're more, diligent or intentional about lowering the berm and not just letting a sesh event, catch us on, flat-footed and lowering it by accident. This time it worked out great. We've got a great, lucky track record on the berm, but we want to be more intentional in the future about it. So.
Thank you.
Yeah.
Great. And then do you have any other updates?
Nothing too crazy. I think just maybe an update on the CMP. We're going to incorporate, salinity management that we've discussed here as a group into that. But one of the things that we're doing in our CMP, and hopefully everybody's heard this like 100 times, is we're kind of segregating out these, management activities from the CMP. So the CMP is really how we make decisions when someone's asking to use sovereign lands. And then because we don't want these things to get, dried up and dusted sitting on a shelf over 10 years, we're taking the like day-to-day management, the information, the kind of book report aspect of our old CMPs and putting that on our website and making an interactive, here's the lake level, here's the salinity, here are the things that we're doing today. It doesn't really make it just It's just more about transparency for the public so people can see like what we're doing. And then as we learn new information or like, develop protocols for like the Berm or management of that, we don't have to wait 10 years before we can tell people how we're doing that. We can update the website immediately and show people how that works. So we're really excited about that. I think it'll have there'll be a lot of the work that we've done as a committee that shows up. There will also be a lot of other agency partner information. We'll try to filter people to the appropriate places so they can go to the right spot to get the information. So we're not having to retell any of your stories, and we can direct people to the right spots. So that's probably the biggest thing there. And yeah, I don't think we have much else to update. Unless anybody has specific questions.
One of the ideas that Envision Utah is incorporating in the BIP is for these various scenarios, an if-then kind of thing. And I think it helps the public understand that if we don't do something, then this could be the outcome.
Sure.
If we do something in a timely manner, then this is what the benefit of that management decision is. So I don't know.
That's great. I think we can try to consider that and incorporate. We have, kind of a limited amount of funding and time to finish this. Like it's already gone a little longer than more expensive than we would like. But I think those are the kinds of things that, given the fact that we're taking that component out of the plan, we don't have to wait 10 years to do that. We can work on that now and develop that tool out. So if Envision or someone else is doing that, that's the beauty of segregating these things is we can be more fluid. One thing I actually did just think of that I would like to update on that may be something we need to discuss later is, we are working through the Newfoundland Basin project. That's something that's still chugging forward, and we're trying to convene all of our agency partners to, help and work through, collecting data and making sure that's a good project. That will likely have some salinity impacts, based on what comes back to the lake, and then also, any water source we get is going to change these dynamics, and it's going to increase the need to measure. And I think we're going to, work with USGS and others to make sure that we're measuring inflows and chemistry of water that comes out of that. And then the other one is, with our purchase of the US Magnesium facility, we also have all of the water that gets stopped in Stansbury Bay that we think will, amount to a pretty significant amount of water. But also there's a ton of accumulated salts in Stansbury Bay. And so we're working through different angles to figure out just exactly how this will work out, how we can potentially return water that would otherwise make it through Stansbury Bay to get to Great Salt Lake. We did get, I think it's finished. Well, I guess we'll see. We don't have it until the check's in our hand, but I think we got a $4.5 million appropriation from Congress to implement this project. So we're hoping that we can start to do some of this work and get, find another source of water that doesn't have intermediate users that would be valuable for the lake. So anyway, lots of cool stuff happening.
Cool. Yeah, there's a lot going on.
Yeah.
And then Jim, from DWQ, you have updates? Any updates?
No, nothing different than, just to reiterate, there were some questions about our rule and how this would apply with increasing salinity. And I'm not sure exactly what I informed this group on, but we did have some conversations. And, our rule is kind of what it is. If the lake does reach 150, there is a limit to allowing additional discharges to the lake. So, it's our hope is that, management is careful not to do that so that we're not put in that position. But other than flexibilities, there really aren't any, with the exception of some of the built-in off-ramps for de minimis discharges. So, if there's any questions about that.
Any questions for them? If not, I think we can move on to proceed.
Cool. Ryan's going to give us the lowdown on recent monitoring, recent observations since the berm has been lowered.
All right, this is what we've all been waiting for. So next slide, please. All right, before we get into the data, let's just review the setup at the new breach, okay? So we have the south side of the lake. This is the Causeway Bridge here. So we're looking at a cross section, the bridge deck, south side of the lake on the left side, right, north side of the lake to the right. We're indicating the lake bottom with this brown color, and the berm is indicated here on the north side of the bridge. And then we have an uplooking acoustic Doppler current profiler mounted to an anchor. And it's measuring velocities at 10 different cells or 10 depths throughout the water column. So cell 1 is close to the bottom, and cell 10 is the shallowest depth. Keep that in mind as we look at data going forward. So the cell width, so it's measuring velocities in the center of these cells, and the width of each cell is 1.3 feet. We're making measurements, calculating measurements every 15 minutes, and there's a 5-minute averaging interval. And these data are available to you via the National Water Dashboard. It's updated about hourly there. So the station number associated with that data is 100, 125. Okay, so just kind of keep this schematic in mind. And we all know that we have south to north flow overtopping the north to south flow. So everybody's clear on that. All right, let's move into data from that uplooking velocity meter. So on the y-axis, we have velocity in feet per second. Here's the 0 mark. This is 3 feet per second at the top. It's negative 5 feet per second at the bottom of the plot. And we're showing data from July 2000, or excuse me, July 9th, 2026 through the current period. And I've indicated where you see a big difference in the data leading into the berm modification. So prior to berm modification, you had the cells, these cells in the positive territory above the 0 mark on the plot. These are the south to north flows, okay? So those velocities are hugging around 0.5 feet per second. The velocities that are measured closer to the bottom, they're hugging around the 0 foot per second or slightly negative. And then we modified the berm, and it's completed sometime on the 16th, I think. The berm modification complete. But anyway, we can even see when they started working on it in this data set, we see those shallower velocities jump up to over, between 1 and 2 feet per second. And we see some of these velocities that are measured closer to the bottom, going to larger negative values, around 1 foot per second. Okay, so the big picture with this data is that when we modified this berm, when it was lowered to 4183, south to north velocities increased a little bit, and north to south velocities increased a little bit. Okay, well, that was the intent of this, right? Was to get more north to south water moving to the south arm of the lake, and we see evidence that is happening by these more negative north to south velocities measured in those deeper cells. Does that make sense to everybody? Okay, that's observation 1. Observation 2. We still see these big spikes in this data that are happening periodically. So after berm modification, the velocity response to wind events is still very evident in this data. These are the result of wind events causing, in this case, we had a wind event blowing out of the north, and at some point, the dynamics of that causeway changed so that north arm water was all north arm water starting to move south. And so all the velocities measured throughout the water column are dipping down into this negative territory. A negative velocity is a north to south flow direction. Does that make sense? Okay, and we see many wind events impacting the data through this period, including a wind event that was pushing water into very positive velocities south to north flows, so almost uniform flows south to north. So the entire water column then starts to shift and blows to the south from the north to the south in an event like this, and it's just vice versa on an event like this. Does that make sense? Okay, we saw these wind events impacting the velocity data set here previously, so we still see that. Next slide. All right, now let's just zoom in on a 2-day period in that data set. So from July 18th to July 20th. And let's take a really close look at the complex nature of these velocity measurements throughout the water column. So these numbers, well, first of all, the zero velocity line is indicated with the bold black line. Anything above is a positive velocity, south to north. Anything below is a negative velocity, north to south. All right. The blue line indicated with the number 1 here, that's that first cell measured by that uplooker. That's the deepest cell that we measure. So that velocity at that blue line, or represented by the blue line, is close to this zero mark, the zero line on this plot. Now working our way up the water column, as we step up into the next layer of water, above layer 1, the velocities are slightly more negative. So that water is moving a little bit faster, heading in the north direction. As we go further up, the water velocities heading in the north direction are even stronger, higher velocities. Okay, so close to the uplooker, the north to south velocities are slow, and as we work our way up, those north to south velocities start to pick up. All right. Here's cell 4, so working our way up the water column, still in the negative territory here. Pretty strong negative velocities at time, but pretty big fluctuation. This is 4 up here, and this is 4 down there. We're starting to get into the transition zone, where we're getting out of just that north, highly brine water, and we're working our way up the water column into the south water. So by the time we get to cell 5, it's way above the zero line, and it can come significantly below the zero line. So we're in that transition zone, okay, where the north to south water, you know, it's just cruising over each other. But this cell 5, 4, and 5, mostly 5 in that transition zone. That's at about 4185, by the way, in terms of the data, the Great Salt Lake elevation data that we're all familiar with. Now we work our way up the water column, cell 6. These are strongly positive velocities at 0.8 feet per second. And then, you know, cell 7, stronger velocity still. Cell 9 or 8, stronger velocity. And then as we get close to the top of the lake where we're measuring velocities, cell 9 and 10, the velocities are actually a little bit lower, at least in this little slice we're talking about right here. The point here is it's a complex velocity profile, but in general, we're accomplishing what we wanted to accomplish with this Berm modification. We're seeing stronger velocities in the north-south direction post-Berm modification. Any questions?
What was the elevation difference between each of those different profiles? You say
1.3 feet. Well, 1.3 feet is the cell width. Yeah, it's 1.3 feet distance between them. Yeah.
So just to make sure I'm understanding, those 1, 2, 3, and 4 would be representative of like 5 feet of north to south flows.
Yeah, yeah. And that's at depth. Yep.
And we only had, during this time period, we only had like less than half of a foot of difference.
Less than a half a foot of difference between
Head difference between north and south.
Yeah, I haven't looked into that in detail, so.
But it's interesting because I think one of the things that we were working off of back when we were looking at like, you know, when we can see north to south flows is like, you know, this much of a head difference, you can see that north to south flow. It's just interesting that we're seeing, you know, such an increase in that flow at those lower depths. I don't know if that matters, or maybe the difference in head difference is what drives that. But I think, you know, before when we were looking at things like, you know, siphons or, you know, other ways to do that, I recall that maybe there was like a 2 or 3 feet of difference that could be worked into that, but maybe I'm not thinking of that the right way.
I think right around 12 to 16 inches is kind of if we're below that, we see much more north water coming down. And so I think where we are with that 6-inch differential is probably the most north to south flow that we see. Because now the density is much more important. We don't have enough head differential to push water north. but you get more differential now that south to north becomes more important.
Okay, well, these uplookers, this technology it's been around a while, and I find it very remarkable technology. And so this gives us some pretty precise information on what's happening with the flow dynamics. So, you know, one thing to keep in mind, that's cell 1. So we have the uplooker, it's sitting on an anchor that's about a foot thick. And then there's the uplooker sitting on top of the anchor. And then there's a blanking distance where the uplooker can't measure velocity. There's some distance right above the sensor where it can't measure velocity. And then we hit cell 1. So we've got a distance of, from here, yeah, this blank space, you know, from the blue up to the number 1. That's a blanking distance where we don't have data. Let's go back to the velocity slide. But even with that, we know that that's cell 1, that where we are getting data, which is going to be, it's almost like potentially 3 feet above the bottom. Those velocities in cell 1 are really low. But we have a lot of uncertainty what happens below cell 1. Because we see these really low velocities in cell 1, we think that water right now is not moving quickly. It's almost like there's the water's coming over the modified berm and just kind of shooting through, represented by these, let's go to the velocity slide, represented by these higher velocities here. But the water that's deeper than cells 3 and 4 is relatively quiet. Does that make sense?
Yeah, so in that kind of redder area right at the bottom, Mike Freeman, his observations are that that's relatively like a stagnant pool. And it's actually advantageous that we have our instrument where it is, because just that's pretty quiescent water right there.
Okay, next slide. All right, so let's look at the actual field measurements of discharge that we're making with the downlooking ADCP mounted to a little boat that we can tow across. So we have discharge in cubic feet per second on the y-axis, going from about 300 CFS at the bottom to 900 CFS at the top, showing data from October 1st, 2025, out to yesterday. So these are field measurements of south to north flow shown on this plot. Let's just kind of get over here to the right side of the plot where all the action is. The measurement made on July 10th, just before the berm was lowered. So this is indicated of July 16th, right? When the berm was lowered. So that measurement just prior to that event was 500 CFS. July 17th, the day after the berm modification is completed, we measured 376 CFS. July 24th, back up to 928 CFS, but there was a south to north wind event. So water's pushing, or wind is pushing water from the south to the north, causing a higher discharge on that day. August 5th, a couple days ago, very quiet conditions, or was that yesterday? Thank you. Yesterday, quiet conditions, the discharge measurement came in at 542 CFS. So just kind of looking at these versus these, not a huge dramatic change, you know, just kind of order of magnitude-ish. But right now we're about 540 CFS, at least as of yesterday, south to north. Next. All right, north to south. Same axes definitions, other than this is 0 at the bottom, and this is 200 CFS towards the top of the plot. And let's just go right to the right side of the plot, get into the action on July 10th. We measured 23 CFS. Remember, there's higher uncertainty with respect to these north and south numbers. Part of it's due to the blanking distance we just talked about, but there are some other factors at play as well. On July 17th, the day after, 84 CFS, not a huge jump. On July 24th, 16 CFS, back down. But this July 24th is when we had that significant southern wind, south to north wind event. It's not surprising that that value is suppressed because of that wind event. August 5th, this is quiescent conditions, we feel pretty good. We feel like the uncertainty related to this August 5th measurement is less than the uncertainty related to July 17th and July 24th. August 5th came in at 233 CFS. All right, this is great. This is a big jump from where we were. So I think the story here is right now it's looking like this berm modification is doing what we wanted it to do. Flows have increased significantly from the north direction towards the south, moving salt, moving nutrients to the south. And I think that was the objective, right? All right, so the uncertainty that I mentioned at last meeting with these north to south flows, we're gonna have much more to say about this in the coming months. We're doing a lot of work to try to pin this down, but for now, the uncertainty is higher for these north to south values relative to the south to north values on the previous plot. But we're working through it, and we think this August 5th measurement is the better of the three we've made since the berm was modified. So I'll just leave it at that.
Your question?
Okay,
Great.
And then I just threw in salt fluxes, like what this would mean for salt flux. So the orange line here represents July 16th. And then to the right of that represents the period where the berm was lowered to 4183. And this is largely controlled by the discharge. So you see like these two, we're still getting a lot of net south to north transport of salt because those discharges were high. For this one, we have most confidence in the discharge reading that was made yesterday. We're approaching kind of this net zero flux, and we'll be curious to see if we start trending into import territory where we're starting to get salt from the north to the south. So we'll be building out this data, but just preliminarily, it does look like, based on the measurements that were made yesterday, we're trending toward certainly lower net fluxes to the north and potentially starting to import salt from.
That's great. Any questions on that?
I was just curious, with what you're seeing on the flux of south to north and anticipating whether or not we get a north to south or if it just like maybe stabilizes. Is that in line with what you had anticipated would happen with the flow regime that we're seeing from north to south and reestablish one of those flows?
Mm-hmm. Yeah, it is that certainly that trending down toward zero net flux of it being equal is what I would expect, because we removed a physical obstacle and now we're getting a lot more salt in from the north. And so, yeah, I would expect, us to be trending toward net gaining of salt. And especially this time of year, because we're getting kind of the elevations to be more equalized. And as Jess said, it's kind of dominated by density at that point, and you get flow from the north. But I will say that I've been looking at kind of how these current measurements fit into like 2021 and 2022. And there's some variability in the patterns we saw in 2021 and 2022 that I can show you that kind of complicate the story. Because I can get into that, but it kind of depends. It depends on water surface elevation differences. It depends on the density differential. But right now we have a really large density differential between the south and the north because the south is so much fresher. So that will also drive flow to the south from the north. So yes, this is what I would expect, but it's kind of a complicated story.
Because I know you all were probably thinking about like taking bets or doing a pool on what the flows were going to be. Did you guys anticipate any certain flow with that lowering, or was it what you expected?
No, I mean, I hadn't.
You guys didn't have an office pool?
No gambling.
That would be against the rules, Ben.
Yeah.
That's a big game. Christine, can I ask you a question about this? I mean, even if it was at net zero, you're still exporting more volumetric water, so you would still expect concentrations to, if you just had a net, if it was at net zero in terms of mass exchanged, but you're still exchanging water, you still expect the concentrations to shift.
In the south arm?
In both arms, I guess.
Yes.
Because you're moving water mass.
Yes.
So Christine,
Yeah.
when you say the trend is a downward trend, but then what are the factors that would, allow that trend to continue? Is it, I mean, obviously the head difference is one of them, but if we're getting to already close to that minimum head difference, what other factors would still have that trend continue?
That's a good question. I don't know. I think really just, yeah, you're right. The physics are what they are, and that the water surface elevation, if the south arm continues to come down more, that would drive more flow to the north. Wind events, this is something also that is, I'm really curious to look more into, but these episodic north wind events where you can get full flow reversal transport a lot of mass. So it can also depend on weather, because during those events, we just managed to get these huge slugs of salt into the south arm. That would also help us trend more into negative territory. And I think just getting more measurements of like, is that 233 CFS representative? Is that really kind of what we're seeing? And getting more paired measurements will help us distinguish that, because there's quite a bit of uncertainty in those first two measurements we made.
And as we continue to look at this salt flux, as long as we compare it to the actual salt mass and potential changes in the salt mass,
Right.
that would give us a way to confirm or deny what we're calculating.
Yeah, and I think that's what's really great about our monitoring program is because we have two completely independent sets of data. One from the south arm of the samples that GSLUG collects, and then one at the breach. And so we can kind of corroborate both of those stories.
You're doing more monitoring now than what you typically do, right?
Yep.
Can you describe what you are doing? While it's open?
Yep, we're doing roughly every other week. We hit it right after the berm was lowered, as Ryan said. Then we did a week after because we were just trying to capture any, conditions right after the change. And now we're on an every 2-week interval. So, and we'll do that until we raise the berm. Yeah, if
And you're capturing the salinity and the nitrogen.
Yes, we're getting nutrient samples, right, Andy? Yes, I'm pretty sure we're definitely comparing the water quality. Okay, fair enough. We're getting a water quality sample every time they get a measurement for this more intense monitoring. And I'm almost positive nutrients are included in that.
That's what we discussed, but
Yeah.
we're not gonna see the results of the nutrients.
Correct, for a much longer. Yes, exactly. Yep.
Great. I think that's exciting. I think that's what we were hoping we would see, something along that zero or net flux.
Yeah, and there's many other, like the interface, the depth to the interface is changed. It's probably 2 to 3 feet higher than it was before. So we're just getting the cross-sectional area of north to south flow has grown along with increases in velocity. So multiple lines of evidence to suggest there's more flow and constituent flux coming in from the north. Great.
So any other questions on what they've been observing after the berm?
Sorry, did you say the interface dropped a couple feet? Is that what you said?
It's higher. Sorry
It's
if
higher,
I said,
okay.
sorry if I misspoke. It's higher now. So it's probably 5 to 6 feet below the water surface, and before it was like 8, 9, 10. So yeah, it's the north to south cross section has grown.
All right. Well, good. Well, now with all these things that we've learned in the last couple of weeks, you've been crunching numbers.
Right. Right. Okay. Let's see what we get. All right. So taking the I have calculated the fall salinities using a couple of different approaches. One is this kind of standard water salt balance model. And kind of the results of that, I only did predictions for a dry, warm scenario and an average given the conditions that we're under. And the resulting salinity, and I'm predicting through October, so roughly November kind of salinity or a seasonal high, estimated using this method is 138 grams per liter for a dry condition, dry warm condition, and 133 for an average. And not much change in the salt mass really, given the short amount of time between now and the seasonal low. I kind of kept in this simplified way of estimating fall salinities also, which is essentially saying from our spring peak elevation to our fall low elevation, what is kind of a typical decline in surface elevation, what are the associated volumes, and then backing out the fall salinity based on that. And this assumes no real change in salt mass, but using this approach, you get a range of 138 to 143 grams per liter. So those methods, both two different methods, are fairly consistent, around 140 grams per liter for the fall low. And again, our most recent measurements made Tuesday and yesterday were 131 grams per liter. Okay, so now for the spring, we know, moving from fall to spring, these salinity predictions are really controlled by the amount of water. That has the largest lever on the estimates we get for the spring. It's the amount of water coming into the system. But Jeff asked me to kind of play around with a couple of scenarios, and I hope that this captures what you're after. But one is to raise the berm on October 1st. That's arbitrary. Really, if you were to raise it when the south arm hits 4190, that would probably honestly be beginning of September, based on the current rate of change in the south arm. But if we raise it on October 1st, that's one scenario. And then the second scenario is to raise it, not to keep it open and raise it in the spring. And that's just a scenario that Jeff had mentioned. Is that right?
A lot of things.
Okay. Okay, hopefully that captures it. And then there's also the berm height to consider. If it's at 4190, there's a higher likelihood that will be overtopped in the spring at a certain point. And so I estimated that based on previous rates of change to be around February 1st is when we might see overtopping from south to north, and then again start to lose salt mass. So these are the kinds of factors that I was working with. So, and I'm going to display this all using our isomass plots, which integrate elevation, the salinity, and the mass. So starting with our most recent measurements on August 4th, again, 131 grams per liter, sitting at 4190.6 feet in the south arm, and an estimate of 864 million tons of salt. Moving forward to the fall prediction, and kind of just walking through, this is a slightly different approach that I took on the previous two, but this results in 147 grams per liter, and that's trying to account for the amount of salt mass we gain due to the breach being open. And that's based on previous conditions. Almost 20 million tons between now and October is the amount of salt mass that I'm estimating might be added. And then kind of moving forward into May, again, this is largely controlled by the amount of water being added between the fall and the spring. So the different water conditions that I consider are basically a repeat of 2026 runoff. So now it put us at 4190.6. That's the lowest kind of horizontal dashed line you see here. For a mean runoff condition, that's about 2.2 feet of gain. That's 4191.5 here, this middle line. And then kind of an extreme end of the spectrum if we repeat 2023 runoff, which is that high end. And then we have these kind of different salt mass configurations. If we overtop the berm on February 1st, if we assume no overtopping, because like in some of these instances, if it's at 4192, you would not overtop. And then kind of just assuming a median rate of net flux. The scenario 2 is where we keep it open. And so actually in this scenario, and I'll show plots of this, but in this scenario, if you keep it open, you actually end up losing salt, a net loss, because of how, because when you get a pulse of water into the south arm, you end up having kind of a net loss of salt to the north during these seasons of winter and spring. So the results of this is really in, what the take home for all of you are summarized in these boxes. So for a dry, warm condition, estimate of 130-ish gram per liter in the spring. It really, these different scenarios of this salt mass exchange don't change it a whole lot, maybe by 2 to 3 gram per liter, according to these calculations. It's really driven by the water. So average conditions, you're sitting more at about 122 to 125 grams per liter. And then for a very wet condition, 122 to 105 grams per liter. So that gives you some idea of what spring could be like. But I wanted to just make it clear that I based these estimates of the flux and the amount of mass change in the south arm on a median condition. So on a distribution of when the breach was the breach condition was similar to what it is now. So when the berm was at 4183, this is the period from 2018 to 2022. And then for each month, I basically just calculated the net daily flux. So for the box plots that are above 0, that's a net salts export from the south arm. So basically net loss of salts. And then for values below 0, that's a net import. And just so you can see kind of the seasonality of this. And this is really driven by conditions in like 2019 and 2020. But based on kind of all this data clumped together, you really kind of get an import of salt during these months from May to October. That's when you start to get the water surface elevations getting closer together, and you get a net import of salt to the north during those seasons. So keeping it open longer may not be beneficial because you have a net export of salt anyway, at least for the purposes of wanting to get salt to the south arm. But it varies. And so for 2021, this is similar plot monthly. For 2021, based on the conditions of that year, we actually estimate a net import during most of that year. Contrast that with 2022, lake elevations were really low, salinities were really high in the south arm, and we actually had much more frequent salt export. So this is what I've been racking my brain for the last few days of like, what are the conditions now? What do they match most closely? 2021, 2022. We have water surface elevation similar to 2022, but the density differential is much different. In 2022, we had really high salinities in the south arm. And so that difference between the south and the north was less. Now we have much fresher conditions. So the physics should dictate that we get much more flow from the north coming in because of that density difference is different. So just something to keep in mind as we try to anticipate what the flux is going to be now is that it can be quite complicated. And another factor, of course, is like wind. What if 2021 was a particularly windy year with a lot of winds out of the north that would drive a lot of salt into the south? So those are kind of a few other factors we need to be considering as we try to like think about what this year is going to bring. Or at least that's what I've been thinking about. This is just a time series of that same data, net salt flux from 2019 to 2022. You can really see how in these years we had, kind of this nice seasonality. 2021 dominated by net flux to the north. And then in 2022, it really begins to break down, even though the water surface elevations were similar. So yeah, maybe this is too much information and as I try to problem solve it myself, but these are just, yeah. And then water surface elevation, I just overlaid in this black dotted line. So really matches closely when we get these big swings in water surface elevation. You see that salt flux sort of following that pattern. And then these 2 years are just responding very differently to that very same variable, which is the water surface elevation difference. I think this is mostly driven by increase in density in the south arm, but we got to look at the wind too and just see what the effect of that is too. And I will say, these are based on daily discharge estimates made by Sam and Eric, his previous grad student. And with that, I'm happy to take questions. I just kind of wanted to run folks through, as we try to predict what salt flux might be, it's pretty complicated and there's a number of factors to consider, but that the spring predictions, again, are really driven by water. So, yeah.
Excellent, yeah. Doesn't sound like it got simpler.
I know, I was hoping you would. But yeah.
I think you identified a lot of key factors,
So I guess they have a well, so they
key variables that help drive it.
Yeah, and I did have a call with Sam this morning to just try and make sense of all this stuff, and he had a lot of great insights. And so if you want us to try and get to more precise predictions about the salt flux, I think he would have some really good insight in how to do that, just given his expertise of the physics of the new reach. So we can keep working on that if that's of use. And I think I would, try to bring Sam into trying to figure out some of those methods and things. Yeah.
Christine, can you bring that slide back up?
This one?
I don't have a question. I just want to look at it again.
All right. There you go.
No, the one right before this.
Oh,
It shows the predictions, yeah. Thank you.
okay.
So within in the next 2 months or next couple months or month or two, with breach open or the berm low, we have a bigger density gradient
Mhm.
between the two. And so that's where you're saying we should see more north to south
Mhm.
flow. So we'd be mimicking more the 2021 pattern like we saw.
I think so, but I've also expected the same thing to happen in 2022, and for whatever, well, you're right, the density was different. So yeah, maybe it's closer to 2021.
Christine, at the previous meeting, I thought you had like an October 27th.
We did, I didn't do that this time, yeah, sorry.
Well, it seems like there's maybe too many variables, right? Like when we raise it, whether it's now, then what kind of weather. all those things.
Yeah,
I mean, just one general comment is regardless of what happens according to your predictions, we're in a good spot. That's just a general comment I would make. But the other one is when we look at salt mass, it's a tool for us to verify if what we thought was going to happen is actually happening. But in order to try and anticipate what's going to happen, at least towards the future, and refine that ability, I do agree with you. I think at least that's what you were saying, is that we could benefit from SOM's expertise and continuing to model that. I would certainly highly recommend that if funds are available, we would do that.
Yeah, especially as computational fluid dynamics model, which is based on physics, and I think he would be able to give much more insight into flow dynamics. We did also, did you mention this? We surveyed the bathymetry yesterday also of the kind of the breach opening. And so that would also help feed into a model for someone like SOM or Water Resources to say, well, okay, how is this 4183 condition different than 2021, 2022? Because it might be slightly different. And Craig was just mentioning how there could be other factors that are controlling the flow that we may not be aware of.
Because right now there's bathymetry, there's density, and then there's lake elevation and the head difference. I mean, there's already a couple of factors that are playing into this, and there might be others.
Yeah.
Christine, I think in previous presentations, you talked about how, if I remember right, when there is no berm, we expect to see the formation of a deep brine layer. Do we know what time frame that would expect to happen if we keep this open? How that would affect flux?
Brian, what did we measure the last time? Like six months?
Yeah, there was like a
6 months?
6-month lag. Yeah, this is based on the, what were the years for that study?
2016, well, no, 2015 to 2017,
Yeah.
roughly.
And that's published by one of Bill Johnson's graduate students in a journal, so we can point you to it, but it seems like it was a 6-month lag time.
And we haven't observed it yet. There are thermistor buoys out there that might be able to catch a thermocline, and if we could get a water quality measurement associated with that, we'd be able to see when it develops. Another factor to consider is how shallow the south arm is right now. You get a lot of wind action that can actually mix that out. So yeah, we'll see what we see.
If we do see that, do we expect a change in the way that the berm actually flows? Do we expect a difference in the transfer from north to south, right?
With the deep brine layer?
Yeah.
Not to my knowledge.
I think that's putting on that schematic. And maybe not so useful, but we have a kind of a deep pool where our uplooker is right now. I don't know. Let's just do the monitoring and see how it pulls out. Yeah.
Just curious.
Yeah.
More curiosity.
Yeah.
So I think one of the hopes or things that we had talked about was, we saw this decline in nitrogen flux to the south arm. That if we were able to lower the berm and open reach up, we could reestablish the bidirectional flow, hopefully get to a net zero salt flux. But the big question is going to be just what's the nitrogen flux? We're getting more nitrogen now coming from the North Arm, but are we exporting nitrogen? Does that offset the bidirectional flow?
Yep.
We don't know. I guess historically, when we had bidirectional flow, the nitrogen was okay, right? so maybe.
Yep.
Anyway.
It was maintained at certain levels, yeah, and as we know, the breach is the largest source of nitrogen and phosphorus to the South Arm, so.
Fantastic. Any other questions or comments on that? Thank you. Takes a lot of wizardry.
Yeah, and if there are more, if there are specific questions or specific scenarios, I think we could tackle it. Just need a little more, just probably some time to chew on things. But if any of this, if you'd like any of it in more depth, I think it's possible, and we could learn a lot. So.
Great. Thank you. Craig, I don't want to mean to put you on the spot, but I know you've been working with SOM and Utah State on just the hydraulic modeling. Do you want to speak to that, or do you want to? We can do it next time too.
We're still developing things. It's getting closer. I'm hoping that the time will come when, regardless of the salinity difference, regardless of the elevation of the berm, we'll have a more reliable way of quickly estimating the flows through the breach. But I don't have anything firm for you right now. We're looking forward to it. USGS is telling us that soon they'll have additional data for us, and they told us that a couple of months ago. And we're still looking forward to some additional data to help us with that.
Yeah, once again, we're kind of holding the show up a little bit. This gets to the uncertainty in the field measurements, particularly the north to south. But also, we've been doing a lot of work, Andy and Mike Freeman, on developing an index velocity rating for both flow directions. And so that's a standard, way USGS will develop discharge ratings for gauges that are unusual, or where you can't get by with a simple stage discharge rating. So these guys have been working really hard on this, and we're getting close. But the field measurements of discharge, the uncertainty there, that's something we want to make sure we completely understand before we lay out our progress on index velocity ratings, because everything's sort of based on the field measurements of discharge.
So Sanaz is about ready to finish up her work on this, another week or so, and her dissertation won't be done for another 2 years. So we'll have, I suspect we'll have her back again next summer and kind of complete this with the wonderful data that you will be providing us, and we look forward to that.
Fantastic. All right.
That's about it.
Okay. Well, thank you. So I think that was, I have one more thing on the agenda, was just to discuss the salinity management framework, or the guide, the plan. And that's been, I don't know what direction, if, I don't know that anybody's reading that again and again and again. But that's still on the agenda in terms of things that we're working on as a committee. And I think the last change was made in April, and mostly was just to make sure that it was flexible for such issues like nitrogen. That it wasn't too prescriptive, that we would be able to adapt for things like that come up. But I think what we want to try to do is we want to be able to reference it in the CMP, and as I guess another document that the CMP is can rely upon. So we'd love to get it finalized. And is that, Ben, do you think that's something we can move forward with? You want to move forward?
Already, I mean, I'm comfortable with it, but I think, I think ideally, we probably need to nudge people before the meeting, give them a reminder that we're gonna, adopt that. I just knowing how busy everybody is, I would imagine not a lot of people were looking at it right before this meeting, so maybe it's something that we, unless someone feels strongly, maybe we table this till the next meeting, and then a week or so before the meeting, we remind people that they need to hop in and provide any final comments or concerns. Unless anybody is ready to roll. Sounds like we should just wait.
Yep, let's do that.
Okay.
Great. Well, I think then all that's left is to schedule our next meeting. I think if we go by our typical pattern, it would be Thursday, October 22nd. Unless you want to meet before then.
I'd suggest we meet before them just because I think there's a crucial time period in October that we need to decide, if we're going to, raise the berm. That would be probably at least one of the decision points is whether we do it at the end of October as Christine kind of modeled or if we're waiting. And I think we're gonna need a little bit of lead time to figure out, if we're gonna get a freebie again or if we're gonna have to contract it or how that'll pan out.
So, September probably in a month from now.
Maybe, what, is there like any sampling dates that correspond where we could, get the most fresh, recent data that we could say, let's meet this many days after, gives you a chance to do your modelings. We're not like.
For the South Arm?
Yeah, I mean, like this time we're looking at June 22nd. Is there a time frame?
Yeah.
So we could be like a little further along and get a little more
Yeah,
recent.
I know G-Slip was trying to get out last week. It really, it was wind. They couldn't get out and get samples. So yeah, I can try to work with Kyle to see when, we don't know their sampling schedule. So we kind of just respond once they give us the samples. But I can try to just get it. So no, but this time I don't have the samples.
Well, I was just gonna say, if like, it'd be really nice to have the most recent stuff, so when we make a decision or recommendation, it's like pretty fresh, but I would suggest it somewhere like in that first week of October. I think that would be in a, good time frame, and we would know what we need to do, or maybe last week of September at the earliest.
They try to go out, I will say G-Slip tries, correct me if I'm wrong, John, but they try to go out at the first of the month. So 1st of October, if G-Slip goes out that week, that won't give us enough time to look at the data. So maybe 2nd week of October would be good.
Let's do it.
Just looking at October 8th. October 1st is the first Thursday. October 8th is actually the first week, so maybe that might not be enough time.
This is Kyle. I can chime in on this if you guys want.
Yeah, that'd be great.
Yeah, so we just try to keep our nutrient sampling once a month, and in that kind of 4-week time span. If we need to sample the last week of September so that we can have a meeting in the first week of October, we can put that on the calendar now and just sample a little earlier, and that would be fine with us.
I think Thursday the 8th sounds good, and that gives maybe enough time, if that works for everyone.
So, and then I guess, historically, we met at 10 in the morning till noon, and today we're at 1 o'clock. Does 10 still work, in the morning work better? Okay, we'll plan on 10 to 12 on the 8th then. And so then I guess in terms of agenda items, we'll just have our updates on it, and we'll just be thinking about whether we need to make adjustments to the berm and how much.
We calendar the salinity management plan and make sure we send out like a.
Yeah, updated, I'll send it out
So
again.
maybe a week in advance and a reminder the night before, maybe 2 hours before as well.
Do you want us to kind of dig into these calculations a bit more of trying to predict what fluxes might be or flows might be at the breach?
Can we be, I mean, how far in advance do you need to know like what we'd want to model? Like what time frame do you have?
I mean, honestly, for something like this, probably like 3 weeks.
That'd be something maybe we could think of, like, maybe like a month before the meeting and talk about what we're modeling, and make sure we're all on the same page about what's feasible.
Cool. Great. Well, if there isn't anything else, entertain a motion to adjourn.
Actually, aren't you going to discuss the composition?
Oh, the membership, yes, thank you. I did update, so in the agenda that I sent out, we had some changes that we talked about last time, and there we go. And so the changes that we had talked about, Bonnie had pointed out that what we have online still says Westminster College, so we'll update that. And then Paul Jewell had asked to withdraw as a alternate, and then we had a switch between Andrew and Elliott in terms of their roles on the committee, and then Ryan Doherty was going to be our member with Travis, our alternate for the South Arm Mineral Extraction.
Did that work out between you guys?
And then I think we want to follow up, see if there's another university representative we could add to the committee as well.
Hey, Jeff, I was going to take this offline, but since you're discussing it, we're going to suggest if Phil Brown could become my alternate rather than Tim Hawks.
Okay. Yeah. For sure. I was actually wondering about that. Phil's here every time, so. And then you and Kyle. Okay. I had that, and then I went back to the notes and I didn't see it, that we talked about it, but we must have talked about it afterwards.
We talked about it in an email afterwards.
Will you be Kyle's alternative?
Yeah. You have to have an IQ to write this,
I
right?
don't know why.
Mine is-
I don't know why I'm what I'm doing here either, Jones.
So I think the way our charter is, we just, as a committee, we make recommendations for changes, and then the divisions make the final decisions on that. But I think I would entertain a motion. Let's quickly change this to, I'm assuming Kyle's more than happy to serve in that role. And
That is correct.
Thanks, Kyle.
And then if you could make that change for Tim.
Oh, yes. So I'll make those changes, and so I entertain a motion to make that recommendation of these changes.
So moved.
Thanks, Joe. Second. All right, thanks.
Would you please remind me what the role of the Great Salt Lake Commissioner is with the Salinity Advisory Committee, or how, if, when, kind of?
That's a great question.
I'll take that one. So when we are making recommendations to modify the berm, the commissioner plays a role in that. So we inform the commissioner who has ties into the Senate and the House and the governor. So all of those folks are notified and understand what's happening, because this has become a very important issue. One of the, I guess one of the things that's moved the needle a lot on how we manage the lake. So they're very interested, but that is, they're invited to come join, but we've talked about having them on as a member, and I think they would prefer the role of being in the seat of, like, we don't vote, our division leader does water quality, and I think they like the arrangement.
Right.
At least when Brian was there, so we can revisit with that with Hannah and ask her if she's interested in participating as a voting member, but I anticipate she'll have the same time constraints that Brian had.
Sure, yeah, but that's a perfect transitional communication.
Yeah, I think it works well. It gives
Yeah.
the, since Brian was there, they had that in, and it helps us to make sure we have all those necessary communications. So
Right.
I think it works out pretty well.
But it's still water quality and forestry, fire and state lands that approve that recommendation, and then you communicate it.
And
The commissioner,
yeah, we
or how
consult.
does that work?
It's a
Who
consultation.
decides?
So I come up with like, hey, yo, Brian, it's like, here's what we're thinking.
Exactly.
You know, but no, it's just a consultation, and typically
Between the three of you?
yeah, like with this one, we met with water quality, and we had a discussion, and then sat down with the commissioner at the time. And this was kind of in a weird time where there's a transition going on, but we met with the commissioner and said, here's what we're planning to do. Do you have any issues or, any comment? Explained it. And then, the rest of it happened organically. But I think, ideally they have someone from the commissioner's office here that's able to report out on each of these. And so that's been the intent, is to have them, involved in here. But and we'll work on trying to get someone here, whether it's Hannah or one of her folks. I'm sure she'll hire a deputy at some point that can help. So.
P.S. Ben, I am here.
Oh, there's Hannah. Awesome.
Sorry, I had a meeting run long and I didn't want to disrupt the in-person meeting, but I joined. And I would just add, I appreciate the communication that we've had. You all are certainly the experts on this. And so I appreciate Ben's done a really good job looping me in. And I've been trying to be a more regular presence at your meetings and to be in the loop as these decisions are made. And so I'm happy to remain in that role. I don't think that I need a voting role. I just like to be advisory and know what's going on so I can speak well to the subject.
And I'd also just add one other thing that, the commissioner's office has the ability to, tell any division to do something or not do something. And so I think it's also important that, they maintain that ability. We've never run into a situation yet where where I think they've had to use that power. But I think that gives them an option, if they're not in a voting capacity here, to be able to, exercise that role as well. So I think it's a good setup the way it is.
Is that within the DNR or across the state now?
I would have to answer that, but the code originally, I think, it excluded certain agencies, but I think it was, obviously in relation to Great Salt Lake, but they have some authority that way.
Yeah, the legislation just reads state agencies.
I don't know, Hannah told me I need to rip out all my grass, so I did it. It's beautiful.
Great. Thanks, Hannah. And Ben, so I think we had a motion on the table, and just all those in favor of the motion to make these recommended committee changes, say aye.
Aye.
Any opposed? No. All right, I'll pass unanimously. So we'll, I'll get this over to Forestry, Fire and State Lands, and they can approve it, and we'll update the website with this updated list.
So that does leave one that we should talk about at some point again, which is another university position. And I think, if I remember correctly, Brian Crookston had some interest, but maybe some capacity limitations in coming in person. And I think our charter now says that we prefer folks to be here, in person participating. So we should discuss, if there's any holes in our, expertise or our committee on where that we would like to fill. So maybe we can save that and do another amendment if we need to.
Yeah, I know there were, I think in the May meeting, there was, that's not scrolling for me. There we go. There were several names that were brought up. Michael Warner, Brian Crookston, and David Tarbotten. I think Brian and David, I don't know Michael, but Brian and David certainly bring that hydraulics component of it. So
maybe I can just reach out again and just find out from them. Last time I talked to Brian, he seemed willing to do that, but find out from them if they have the capacity to fill it.
Okay. Great. All right, well, anything else? If not, oh yes.
Maybe this is silly, but it's never been explicitly told to me as Bonnie's alternate, what's my role in that?
You're her when she's not here, so you can
So I
vote.
vote voting, okay.
Then you should sit at the table too next time. You can have a cookie, or you gotta have a cookie instead of potato.
Bonnie usually brings
School
more.
requirements.
It's actually a rule requirement in the charter, it says you have to eat those cookies.
I usually eat two.
Okay.
I didn't bring lunch, but I did bring stickers. But that's good to know. It was just never explicitly said to me.
Yeah, I think we hope that if the member is not here, that the alternate would be here. And then the alternate can communicate what was discussed back and then the alternate would also be voter if we needed to vote on anything at that meeting. So glad you're here. So, all right. Well, I think that is all. We will adjourn. Thanks, everybody. We'll see you October 8th.